when considering exponents for calculus, really the main rule that you have to remember is this negative exponent rule. So if I have 4 to the negative third power, that's the same thing as 1 over 4 to the third. If it's written like this, we're happy. But when it's written like this, we need to rewrite it. And generally, it's not with 4 or a number, it'd be written as a variable. So we might see an equation like, or an expression like 1 over x to the fifth. Then we're just going to use our negative exponent rule, which says, okay, well, if it's in the denominator, then I can write it in the numerator as a negative. This would be as if it's over a 1. So I could rewrite that as x to the negative fifth. And it's this concept here that we're going to exploit. We're going to use over and over again. Let's take another example, 2 over x to the fourth. This one's slightly more complicated because I no longer have a 1 in my numerator, so I have to do something with this 2. I like to think of this as 2 over 1 times 1 over x to the fourth. And if I worked backwards, I could see 2 times 1 is obviously 2, and 1 times x to the fourth is obviously x to the fourth. But since I've separated out my fractions, I know 2 over 1 is 2. And since we know this rule over here with the negative, I can say that 1 over x to the fourth is just x to the negative fourth. And it's this idea that we're going to use. It's just splitting this up into 2 separate fractions being multiplied together in order to rewrite this a little bit more easily. It's this fact that we'll use over and over again. So if we look at another example, if I took 3 over 4x to the sixth, once again more complicated because now we have a coefficient here in the denominator. Well, just like before, we'll break it up. So I have 3 over 4 times 1 over x to the sixth. I can break this up however I want, as long as I have 3 times 1 equaling 3, and whatever's down here equals this denominator. So obviously 4 times x to the sixth is 4x to the sixth. Now you notice that 3/4 can't be reduced, and that's okay. It just stays as a fraction. But this 1 over x to the sixth can become x to the negative sixth. So if this were my original function, if I had f of x equaling this function, then in the end, f of x would be rewritten like this. If I wanted to differentiate, I could just take negative 6 times this expression, get negative 18/4 x to the negative 7. Now, if you still haven't seen differentiation, ignore that part, but I just wanted to show the full process in case some of you are there working on it. And the last example we can look at is when we have a negative value. Even if, let's go ahead and put a number here in the denominator. So I have negative 5 over 2x cubed. I'm just going to break it up once again. Yeah, the negative's there, but it shouldn't really matter too much. Just assign it to one of the numbers. It looks closer to the negative 5, so I can assign it there. This, once again, negative 5 halves, x to the negative third, and now you're ready to differentiate.